All right, so now we're into chapter 7 and we're going to get into a bunch of geometry stuff. So today we're going to just make sure we've got the terminology, we've got the notation, and we're starting to build all those really important skills that we need, right? So we've got a line segment. So a line segment has definite endpoints. And when we go to write this, I use my capital letters with a line on top. Okay. For array, so that's one where I've got one definite endpoint, but then it keeps going. So I write my capital letters and I have an arrow. So I can either have a little arrow like that, or you can have a full arrow, but you have an arrow on top. The line, because it keeps going in both directions, you have a 2 directions arrow on top. Makes sense, right? Intersecting is another way to say where they cross. So we've already done some work solving for point of intersection. Okay. Parallel lines are line segments and line rays that never meet. Okay. So for this one, if this was, say, line AB and that's line CD, then I would say that line AB is parallel to line CD. Perpendicular is when they meet at right angles. So remember, a right angle is 90 degrees. Okay. And in that case, let's say this is line AB and this is line CD, then I can say AB, and it's a full complete line, so I do that, perpendicular to CD. Often you see it just as the upside down T. Sometimes you see it with a little square inside, and that's how we write it. Okay. Another word we often see is the word congruent. So that means that it has to be the exact same shape and size. So here I've got 2 lines that are congruent. In that case, I use, so this is a line segment, the equal sign with the squiggle on top. So that's my congruent sign right there. Okay. All right, so point is a location in space, and we always use a capital letter. An acute angle, remember, is one that's less than 90 degrees. A straight angle is in 180 degrees, so that's our line. Okay. An angle is formed by 2 rays or line segments that have the same endpoint, so that's our vertex. So when we do talk about angles, and we say give it some letters, so there's A, B, and C, we would call that angle ABC. So the vertex is always in the middle. So vertex goes in the middle, and that tells me the 2 that are coming in, because it can get quite complicated sometimes. We can have all sorts of stuff going on, and we have to be able to know, right? Like if I drew lines like this, there's A, B, C, and there's D. Well, I need to know which combination am I talking about. So if I was talking about this line in here, this angle in here, then I would have A, D, B. And the vertex is in the middle. And this is telling me I'm coming down A, hitting D, and going up to B. So you got to watch your symboling. All right, an obtuse angle is one that's bigger than 90 but less than 180. And a reflex angle is the angle that's in between 180 and 360. Angles around a point. So let's remember that any angle around a point, so let's call that point P, they all add up to 360. Okay. Add to 360 degrees. And yes, I am going to be very picky. You have to have that degree sign. It is not optional. Doesn't matter if you are typing or writing, you must have those degree signs when you're talking about angles. Okay. So here's an example. Find the unknown angle. Give reasons for your answer. So I know that angles sum to 360 degrees. So that means that 117 plus 146 plus the letter E equals 360. So now I can put my numbers together and I can solve. So let's see. 117 plus 146 equals, oh, look at all this awesome algebra skills are going to come into play. 263 plus the letter E equals 360. To finish solving, we're going to want to minus that 263 from both sides. That leaves me with E equals 97 degrees. And no, don't take out your protractor because these are never, ever, ever drawn to scale. All right, let's do this one. So again, my same reasoning is going to apply. My angles around a point sum to 360 degrees. So that means 360 degrees is going to be my total. I'm going to start over here because it's going to take me a long time. Equals, all right, I don't know, let's start at A here and let's work our way this way. So 99 plus Y plus 109 plus 65 plus 2Y. Whew, that's a lot. But that's okay, we got this. So let's see, 360 degrees equals, I've got a Y here and I've got 2Y there. So I've got 3Y plus, let's see here, 99 plus 109 plus 65 equals 273. So let's subtract that from both sides, right? This is how we solve equations, 273. So minus that from 360, we got 87 is left behind. So I've got 87 equals 3Y. Divide both sides by 3. And what do we get? 29. So Y equals 29 degrees. Nice. Supplementary angles. So that's another way to say that the angles in a straight line add up to 180 degrees. So we can certainly solve for our things in here. So let's start with this one. So I know that my angles have to, I know that x plus 35 equals 180 degrees because they're all in a line, right? So I can call that supplementary angle theorem if we want. And theorem. Rearrange to solve, minus 35, and what do you get? X equals 180 minus 35 equals 145. Nice. Let's get more complicated. So let's see, here I got the little letter I, I've got a funky symbol, and I've got 32 degrees. So don't forget that that square in there means 90 degrees. So in this case, I know that since it's in a line, it's 180 degrees equals unknown plus 90 plus 32. Simplify equals I plus 9 plus 3 gives me 122. Subtract the 122 from both sides. And we are left with, what's that, 58 degrees equals I because of the supplementary angle theorem. Angles in a straight line add to 180. Nice. Okay, ditto on this one. So let's see. We know 45 plus H plus 27, right? Because we go 45, and then we go to H, and then we go through 27. We're all in a straight line. Has to equal to 180 degrees. So that's supplementary angle theorem. Notice I've done this in all different orders, and it's all the same thing. Totally fine. So H equals 27 plus 45 is what? 60, 72? Oops, sorry, that's a plus. Plus 72 equals 180 minus 72 from both sides. And H equals 108 degrees. Last but not least, let's do this one. So here I've got angle X plus X minus 6 equals 180 degrees because they're all in a straight line. Add them up so we don't have anything outside of brackets, so we can really just drop the brackets. X plus X is 2X, minus 6 equals 180, plus 6 to both sides. So we get 2x equals 186. Divide both sides by 2. X equals 93 degrees. Oh, this is lovely. Keep it up. Let's keep it up. What else we got? Okay, so complementary angles are two angles that add up to 90 degrees. Don't forget 90 degrees, right angles, lots of different ways to say it. Here, each one, I've got the 90 degrees in there. Do not assume it from pictures unless it is indicated clearly. Okay, right? Remember, pictures are not to scale. Do you know how hard it is to make these things on the computer? Not to scale. So let's see. Because these are complementary angles, right? We are therefore following the complementary angle theorem, which means 15 plus x equals, see my little square there? 90 degrees. Subtract 15 from both sides, and we are left with x equals, what's that, 75? 75 degrees, because of complementary angle theorem. Okay. How about these ones? Notice I have the letter C and the letter C. That means they're both going to be the same, so that's exciting. C plus, there's my rectangle, or my square, sorry, 90 degrees, equals, they're all going to add up to 180 degrees. I could have known that since that's 90, this is 92, but that's fine. Let's see, C plus C is 2C, plus 90 equals 180. Let's bring that 90 over to the other side, minus 90 minus 90. So that means 2C equals 90 degrees. Divide both sides by 2. C is 45 degrees. Well, that kind of makes sense, doesn't it? Because if this is 90, that means this side over here has to be 90. And if I have to divide it up by 2 equally, 90 divided by 2 is 45. Complementary angles. Okay. We also could have just referred that back to our supplementary angle theorem because we added it up to 180. We could have just done straight 2C equals 90. It all works. So here there's a 90, which means this side has to be 90. So E plus 40 has to equal to 90 by supplementary angle theorem. And then because that's true, minus both sides from 40, or minus 40 from both sides, E equals 50 degrees. Yeah, definitely. Because I know this side has to equal 90. So that came out of the fact that this was 90 over here. So that's where supplementary angles came in. They have to equal 90 because there's my complementary angle theorem. So these guys all combine together, which is awesome. I love how this stuff works together. Okay. Opposite angles. So that's when you draw two lines, the angles opposite from each other are equal. So we've got our opposite angle theorem. Sometimes you see the word vertically in front of it. So it's vertically opposite, means the same thing. Okay. So here, how does that look like in here? So that means since A and 115 are opposite from each other, that means A equals 115 degrees. So there's my opposite angle theorem. And then I say, well, A and B are all in a line. So A plus B has to equal 180 degrees because of my supplementary angle theorem. And now I know that A is equal to 115 degrees plus B equals 180. Let's rearrange here. Minus 115, minus 115. Angle equals, what's that, 65 degrees. Neat, eh? Let's do this one. So let's see. I'm given that this is a 90. So that means therefore V must be 90. 90 by opposite angle theorem. I have another one in here. Let's do, let's pick this color, sure. There we go, there's 53. So that means that one. So the T has to equal to 53. Also because it's an opposite angle theorem. got my degree sign. Okay. And since I know that, I can now figure out U and W. So they make a straight line. So there's 180 degrees. Or I could look at it upside down to get 180 degrees. Or I can look at it on a diagonal. Whatever, it's all going to add up. So let's see. I know 180 degrees has to equal, I'm going to go by the top here, T plus U plus V, because they are supplementary angles, right? 90 degree or 100 degrees, supplementary angles, 180 degrees. Let's stick in the numbers that we know. So T we said was 53. U we're still looking for. V we said was 90 degrees. Put all our numbers together. What's that equal? 143 plus U. Subtract 143 from both sides. 37 equals U. So exciting. What else we got? Oh, so now we're going to take two lines and we're going to put a third line through them. So this third line through them is called a transversal because it's cutting across two or more lines. And when this occurs, we now end up with a bunch of pairs of opposite angles. So just like what we just saw, we've got these guys are now opposite, so they're equal. We've got these guys are opposite, so they are now equal. We've got these guys are now opposite, so they are equal. And we've got these ones are now opposite and equal. So if it's any two lines, so there's nothing special about the line AB, nothing special about line CD. Okay, now we've got four different pairs. The exciting stuff happens when I got parallel lines. So if I have parallel lines, so let's draw a few here. So there's a line, and I'm going to take another line. Let's make it, I don't know, orange. There's my transversal. Okay. So I'm going to tell you that line AB, and it's a line, it's going to be parallel to CD. So there's C, there's D. These guys keep going forever and ever and ever. So I'm going to show you that they're parallel by doing the little arrow lines on them. Okay. This one is my transversal. Transversal. And sure, let's give it some letters. Let's call it, I don't know, X and Y. Why not? Okay, so it cuts across. So now what we're going to see is that if I kind of look at, let's start with this angle right here. Well, opposite angle says that this line is also going to be equal. And then we're going to look and we're going to say, well, this also makes that same angle. And this one also makes that same angle. Okay, that's pretty cool. Well, then because we got straight lines, that means this one, and oh, maybe we shouldn't use X's. This one and this one are opposite angles, and this one are opposite angles, and they're also going to be the same. So as long as I know one number with these guys, I'm always going to know the others. So we put those up in a couple of different ones here. When they are in that cool looking Z pattern, so in our cool little Z pattern, we see that those angles are equal. So we call these alternate angles. In our F pattern, so see how I've got kind of an F going on in here? There's my F right there. We call these corresponding angles. In our interior or co-interior, depending on where you look it up, so that's C, they add to make 180. Isn't that cool? I think that's cool. So when I give you cool looking questions like this, you say, well, notice how these two are parallel lines, and I can make a nifty looking Z pattern. So you can say y equals 50 degrees by the parallel line theorem Z pattern. Huh. And then you can look at this one and I say, well, I've got two parallel lines and this makes an F. So I can now say that therefore x equals 48 degrees because I've got my parallel lines and it's my F pattern. Huh. And then I can finish off. I won't use the yellow because that didn't show up very bright. And I can say, well, I've got two parallel lines and I kind of look like a square C. So therefore, W plus 101 equals 180 because they are the C pattern, parallel line theorem, C pattern. So these are co-interior, these were corresponding, and these were alternate. Neat, eh? Okay, let's do some solving. What are we going to do with this one? Let's see. I've got two parallel lines here. So, let's call this, I'm not that creative. There's AB, there's CD. So I know I've got AB parallel to CD, and I'm going to assume that they're full lines because I don't see any dots to indicate endpoints. So because of that, I'm now going to be able to use my parallel line theorems. They don't line up in an F, they don't line up in a Z, they don't line up in a C, but if I turn you into a Z pattern, that turns this into 38 degrees. And then I can figure that one out. So let's call you angle. Let's take a Q here. So let's say angle DQB equals 38 degrees. So that's my parallel line theorem Z pattern. So then that means x plus 38 degrees equals 180 degrees because they are in a line. So that is my supplementary angle theorem. Well, now I can finish off. Perfect. Minus 38 minus 38. X equals 142. Right? That makes me 50, 80. Yes. Good. Beautiful. Let's take a look at this one over here. So remember I said once you know one angle, you know everybody else. So opposite angles says that this one over here is 131. So angle, I've got lots of letters on this picture, FGJ equals to 131 degrees. So they are opposite angles. And that means also, if I do my F pattern here, angle GHK also has to equal to 131 degrees because I've got parallel line theorem and I just used my F pattern. So if this one's going to be 131 degrees, well, that means this one has to be 131 degrees as well. So angle EHI has to equal to 131 degrees because it's now opposite to angle GHK. Nice. All right. So then that leaves me with all these other ones. So if I go back to over here, so if I look at angle DGF, okay, well, that one makes a straight line with 131. So I can say 180 minus 131 because they're supplementary angles. That gives me 49 degrees. So that means this one over here is also going to be 49 degrees because they're opposite angles. I'm going to have to keep going over here, sorry. Angle HGJ is equal to 49 degrees, opposite angles. And then, oh, I could use C pattern too with that one, sure. And then I can use the same kind of arguments for over here. I could do an supplementary angle. I could do an F pattern. I could do a Z pattern. Sure. Angle, let's do Z pattern because that one's fun. Angle EHG equals angle, what was that? HGJ? HGJ, because of the parallel line theorem Z pattern. So that means it's also equal to 49 degrees. And who's left? Angle over here. So that leaves me with angle IHK is 49 degrees because it's in opposite angles. So much fun. So you really only have two angles in this combination. Let's do some with some algebra here. So I know that if this is 70 degrees, then this angle here has to be 70 degrees. And I don't have any way to symbolize it here. So I can give it, you can give it endpoints like we did up there. You can also give it a new letter and call it angle Y maybe. Angle Y equals 70 degrees because of the parallel line theorem F pattern. So then I look and I see, well, these guys are opposite here. So that means that 70 degrees is equal to x plus 16 because they're opposite angles. Well, and now we can solve. So minus 16, and, oops, what's that? 54 equals x. So there's all sorts of combinations in here that we can look at. All sorts of cool things. Here I've got a nice little C pattern. So I can say that 2x plus 128 equals 180 because of the parallel line theorem C pattern. Finish solving. So let's see. What do I gotta do? I got a minus 128 from both sides. So that leaves me with 2x equals 52. Divide both sides by 2. X equals 26 degrees. It's very satisfying. I find this stuff very satisfying. And then I've got one last one. Hang on, let me rewrite. Okay, so I didn't know if I'd have enough space to write up there. So let's do it here. Let's see. What do we got? We've got 72 and x make a line. So I can say 72 plus x equals 180 degrees because they are supplementary angles. So minus 72 from both sides. X equals 108 degrees. So now I know that that's 108 degrees. Let's see, who's this one going to line up with? Well, that looks like an F pattern to me. So I can say that x equals 5y minus 3 because of parallel line theorem F pattern. So let's sub in our numbers here. So we know x is 108. 5y minus 3 plus 3 to both sides. That gets me to 111 equals 5y. Divide both sides by 5. And y equals 22.2. And that's it.